The recent publication actually was basically on Parkinson's disease. So here, like Parkinson's disease is a disorder of like movement and like muscle control. So which is basically caused due to the loss of dopaminergic neurons from substantial nigra in the midbrain. So we have started from a very interesting molecule, which is a kinase, that is cyclin-dependent kinase 5. Since our lab has been working with this molecule from the very beginning, so what happens is in the stress conditions, this CDK5 gets hyperactivated. So once it's hyperactivated, it leads to phosphorylation of multiple substrates, and which leads to activation of multiple pathways, which are known to be very much linked with neurodegenerative disorders, like again, Parkinson's disease and Alzheimer's disease. Basically in this work, we have found that CDK5 can also phosphorylate CPLA2, which is cytosolic phospholipase A2, and in the two phosphorylation sites, that is one is serine 505, which was previously known, and a novel site that we have noted in our paper, that is threonine 268. So what happens when CPLA2 gets activated due to phosphorylation, it gets translocated from the cytosol to membrane, and when it's translocated to the membrane, it leads to activation of certain signaling pathway, which leads to synthesis of arachidonic acid and prostaglandin E2. So once there is an increase in prostaglandin E2, is a hallmark of neuroinflammation, which is previously known, and this chronic neuroinflammation ultimately leads to neurodegeneration, which is very much common in Parkinson's disease again. For me also, like since this was my first author paper, so whatever I have done throughout this paper was new for me, and since our lab is also newly established, so everything whatever we have done was very much new for me, and it was a great learning experience. And also the simulation study that was done by Saman Fateh, and it was like quite interesting for me, like how the things, like I've got to know a lot related to simulation also. So first, like we have generated the mutation, and we have checked whether this particular these two sites, if we target, like initially we have done some cell culture related studies to at least check whether there is neuroinflammation working, like happening in the astrocytes treated with MPP, which is known as a cell model for Parkinson's disease. So there we can see upregulation of phosphorylation of particular those two sites. But again, if we like mutate these two sites, whether it will affect the activity or not, which was not known to us. So we have gone to the molecular simulation study, and we have found that interestingly, the architecture of the protein is changing. So which means the activity can also hamper for this. And also in our, like, we were lucky to find that yes, like not even the activity, the translocation of the protein from cytosol to membrane was affected due to this mutation. Actually, we have gone through a lot of hurdles also during this review process, because this review process, I feel, is most frustrating, also the most learning, process. So since the most challenging part was, we had to do this, establish this in a mouse model. Getting a Parkinson's disease mouse model in IGIB was a difficult task again, which delayed our work a lot, because to acquire a mice model from some other institute, start working on the mice model, and get positive results, or work set up multiple of experiments on mice model was a difficult task, because since it was in the reviewers comment, so we had to do it. And so it delayed our work around a year, so so it took a lot of time. So after that, it was a great relief, actually. So we are actually establishing this particular, we want to check this particular pathway also in type 2 diabetic brain. So we are mainly now shifted to type 2 diabetes. So since we know that type 2 diabetes is very much linked to neurodegeneration again. So we want to again find the role of CDK5 in neurodegeneration in type 2 diabetic brain. So mainly this have shifted to a different model now. So we are trying to find a connection between type 2 diabetes and neurodegeneration. Like, I'm very much thankful to my senior, Mukesh Sani. So whatever problem I face, I can just go, and the first person to approach is him. And he will always, like, he is not working on this particular project. His project is totally different. Like, he works on Wilson's disease, but he never says no to anything. Like, he will read for me, he'll get a solution to me. So I am very much thankful to him after my PI. So my PI is always the first, but he have really helped me a lot.